Figure 2 represents a closed circuit with three resistors, R1 10 ohms, R2 15 ohms, R3 12 ohms, and a current of 2, that is 20 amperes. Use it to answer the question that follows. We have this diagram which has three resistors and a voltage supply, and we are taught to determine the total voltage across the circuit. So we have this connection. So first of all, this connection is of series connection, is a series connection, because in parallel we could have the resistors in this arrangement. We could have the resistors in this arrangement. They are connected across one another in the circuit, like that. So in this case, now we have a series connection. We are taught to determine the voltage, and as I always say, when you are calculating, before you calculate, determine the formula to use. So from this, we are taught to find voltage. How does voltage relate, or else which formulas do we know about voltage? Here we have resistance, we have current, and we are taught to find resistance. So we can easily apply the Ohm's law, which is V is equals to IR, where I is current in amperes and R is resistance in ohms. So in this case, voltage is what we are calculating. I we have been given 20, and the resistance in this case, because we are taught to find voltage of the circuit, we have to apply the total values of the whole circuit. So if it is current, it should be current of the whole circuit, and if it is resistance, should be resistance of the whole circuit. So this is a series connection. We have been given, let's say this is R1, this is R2, and this is R3. So to get the total resistance in a series circuit, what do? We add the individual resistances. So in this case, our RT, which is total, will be R1 plus R2 plus R3, which is 10 plus 15 plus 12. When you add this, you get 37 ohms. Now we have the resistance. We can apply it to the formula. So we have our voltage now being equal to 20 times 37. And we are going to get 740 volts, which is now the voltage across the circuit. Then, for example, if we were calculating individual voltages in the resistors, we could apply the current in that particular resistor plus the resistance in the particular resistor. If it is resistor R1, we multiply the current plus the resistance R1, which is 10. And remember, in a series circuit, current is the same throughout the circuit. So 20 amperes will be the one in R1. It will also apply in R2 and R3. But voltage is not the same. So you have to know how a series resistor circuit, the characteristics of it. Current is the same, voltage is not the same in all resistors. Also, to get the total resistance, you have to add the individual resistances. Those are very important formulas that you have to note.